Okay, just to recap what we learned in the previous video, okay, what we saw in those two examples is that when you have similar figures, alright, if you know the scale factor of similar solids is A to B, then the ratio of perimeters is also going to be A to B. Alright, so the scale factor is equal to the ratio of perimeters, or the ratio of any two sides is equal to the ratio of perimeters, because they both represent lengths. They're both measured in units. Alright, the ratio of corresponding areas is going to be the scale factor squared, which means we could write it like this, or like this, a squared to b squared. Alright, and by the same token, since area is measured in square units and volume is measured in cubic units, if you know the scale factors a to b, alright, the ratio of volumes is going to be a to b cubed, or a cubed to b cubed. Alright, so what does that do? Alright, that's really important because it allows us to find the volume of a figure that's similar to another figure when we only know the scale factor and the volume of one of the figures. Alright, we don't have to go through using all the formulas to find volume or to find surface area. Alright, and let's practice that in those next examples. But first, I just want to give you like a little visual of why this makes sense. So here I'm going to draw a cube, alright, and that's going to be 1 by 1 by 1, okay, cube, alright. Then I'm going to draw another cube that's going to be 2 by 2 by 2, okay. Now let's look at the relationship between these two, okay. They're similar, alright, I'm going to give that. They're also going to have a scale factor of 2 to 1. So if you go from there to there, it's 2 to 1. If you go from there to there, it's 1 to 2. Alright, well, actually the other way around. But the ratio of the big one to the small one is 2 to 1. Okay? So if we look at just the area, alright, just the area of the face, alright, that's 1 square unit. Okay? Well, if we increase this dimension and this dimension by 2, well, now you could fit 4 of these squares in there. So since the side got twice as big in both directions, length and width, the area can now fit 4 times as many of the original square unit on the surface area of the cube. Okay? And the 8, so 2 cubed is 8, alright? That means that we could fit 8 cubes in this bigger cube. So like there'd be one of them, okay? There'd be one behind it. It's kind of hard to draw. I'm not the best 3D drawer. Alright, there'd be one over here. Alright, I know it's getting a little messy. So you'd be able to think of it this way. You'd be able to fit 4 of those cubes on the bottom and 4 of those cubes on the top. Meaning you could fit 8 of the original cubes in this bigger cube because the volume got 8 times bigger because the scale factor was 2. 2 cubed is 8.